This is a quick video about how we think about boiling point and freezing point with a graph like this. So this question asks, moving to the right on the graph means adding energy. So imagine like putting some water on a stove, and this is saying like if we increase the energy, if we put energy into the water from the stove, then the temperature will go up and up and up and up. That's what this says, water being heated as a liquid, until we reach what we call the boiling point, and then we'll see the water boil. So the temperature doesn't go up, but the energy is going to actually transferring the phase, changing the phase of the liquid water to the gas water. If we were able to collect that gas, we could heat it even higher, which is what this part of the graph is showing. Or if we were to take heat away, meaning moving to the left on the graph, that would make the water cooler and cooler and cooler until we start taking energy away to change the phase to ice. So we can see from this graph that the boiling point of this substance is 100 degrees Celsius, and the freezing point of this substance is 0 degrees Celsius. This substance is water, and specifically it is at 1.00 atmosphere. So it's also true actually that the boiling point and the freezing point will change if we change the pressure. As we know, in Denver, the boiling point is lower because the atmospheric pressure is less than 1 atmosphere. So the question, why does the temperature increase at some points and not others? The answer to that question is sometimes the energy that we add is going to raising the temperature. Sometimes that energy is going to changing the phase. Now, down here, we see the same looking graph, and I'm sorry, I didn't actually change all these things that say water. They shouldn't say water anymore because this isn't water. This is some mystery material. So let's actually double click on it and we can tell, let's get rid of this. This is not water anymore. This is some other thing. It's not water, it's like a mystery material. And we can ask questions about this mystery material, like what is the boiling point and what is the freezing point? By looking at the graph, we can tell that the boiling point is like 170 or something. It is not 100, which we saw for water. It's still the point where we stop changing the temperature and we start changing the phase, but that point is not 100 degrees Celsius. It's a higher temperature. Similarly, it looks like this material is freezing at negative 100 degrees Celsius. And I can tell that by looking at this on this axis over here. So you might see some questions like, what is this mystery material? And you want to use the boiling point and the freezing point to tell what exactly that material might be using like a chart or something like that.